Hello guys, so today we are solving this problem, find kth bit in nth binary string. So given two positive integers n and k, the binary string Sn is formed as follow. So see here, S1 is starting with a 0. Okay, then if we want the next, then Si, so any Si would be, so Si minus 1 string plus 1, we are making this plus 1, and then we are reversing this Si minus 1. And after reversing, we are flipping all the bits of this. Okay, so reverse and then flip of the strings. So this is how it makes. So let me generate these numbers so that things would be very clear. Okay, so for example, this is our, let's say our S1 is always starting with the 0. Okay, so this would be our 0. So what about S2? So S2 would be look like this. So we have to take the original one. So this is S1. So we have to put it like this. And then we have to bring 1 here. And then we have to make the reverse and flip of it. So reverse is 0 itself and flip, then it would become 1. So right, so this would be our S2. Now let's say if I want to make the S3, what would be S3? First of all, we will put this entire string as it is. So this would be 0, 1, 1. Okay, then we would be putting here 1. Okay, we are adding the 1 after adding the original string of previous step, this guy, right? And then what we are doing, we have to first of all reverse it. So let's say I'm reversing it here. So how it would look after reversing? It will look like this, 1, 1, 0, right? And then we have to flip it. So reverse and flip. So if I flip it, it would look like 0, 0 and 1. So this part I have to put again here. So then we have to put 0, 0 and 1. So this would be our S3. Similarly, if we want to go to S4, we have to take first of all this entire string. So it would be like this thing, 0, 1, 1, 1, 0, 0, 1. This would be, we will put as it is, then we would put 1 because 1 every time we are adding, and then we have to make the reverse of it and flip the reverse of it. So if I go from here, I can directly put here. So this would come here 0, this would come 1, 1, 0, 1, 1, and these three are 0. So 0, 0, 0, and final this is 1. So reverse and flipped. Okay, so this part is the flipped one. So this is how we have to basically generate our strings, or any string we can generate in this way. Now you guys can observe few things here. You would have observed here that whatever string it is, we are taking the half string is the previous step, right? So see here, we generated this S3. So this part is basically the S2, right? This is string, and then this part is the reverse and the flipped. Okay, so then we are constructing in this way. So you can observe the length of any string, any length. So what would be the length of it? So if n is the let's say if we want to get the nth string size, what it would be? It would be 2 to the power n minus 1. You can observe it clearly, right? So see here, if we want to find the length of this string, what it would be? It would be 2 to the power n. So n is 1, right? So 2 to the power 1 minus 1. Right, so 2 to the power 1 minus 1 is equal to 1, right? So this is the length of it. Similarly, you can check here, it should be 2 to the power 2 minus 1 because we are taking the nth string. So 2 to the power n minus 1, so which would be 2 to the power 2 minus 1, which is basically 3, right? Similarly, you can check here as well. So s equal to this n equal to 3, right? So 2 to the power 3 minus 1, so what is the size? Size should be 7 only, right? So this is the general formula, that if we want to get the nth string size, then that would be 2 to the power n minus 1. So we can also write this 2 to the power n minus 1 like this, 1 and left shift operator n times. So this also represent 2 to the power n and minus 1. Okay, because this basically, this part indicates 2 to the power n. So we can also write in this way. So don't get confused that what this is in the terms of left shift operator. Okay. So now we will also look for certain other terms before going to the solution only. Okay, so guys, just before jumping to the solution part, we have certain few more things. So suppose there is a bit called 0, okay, and there is one counter, let's say invert counter. So initially its value is 0, okay, invert counter is 0. Now if I flip this guy, this 0 to 1, this will become 1, right? And invert counter would become 1 now, okay. If I make another flip, this will become 0, and this guy counter would increase to 2. If I another clip I make, this will become 1 and counter would become 3. If I another clip I make, this would become 0 and counter would become 4. So you observe, whenever we have an even number of the counter, every time the value is same from where we started. Okay. Similarly, we could have start with the 1 as well. Let's say we are starting with 1. So counter by 1. Initially counter is, this invert counter is basically 0. So if I flip it to 0, at that time counter is 1. If I flip it again to 1, then counter was 2. If I flip again it, then this will become 0 and counter was 3. And if I again flip it, this will become 1. So now here you can observe, whenever it is even number, this value is same from where we started. Doesn't matter if it is 0 or if it is 1. So whenever invert counter is becoming the even number, the value is same. See here, 0 is considered 1, so value is 0 and 1. Then we come here, again that value is 0 and 1. If we come at 4, value is 0 and 1. So in general, I can say that whatever bit we are starting, if we are keeping in a counter as well and then flipping it, so at the point of the even counter, the value would be same from where we started. So we should keep it in mind, because we will gonna use this this concept in our solution. Okay, so now we'll go for our solution. So what to do? So this you observe this point k equal to len by 2 plus 1. This is middle point basically. Now you guys might have a question that why I'm making plus 1, why not only len by 2? Because we are starting from 1, right? K is starting from 1, n is also starting from 1. See here, s1 equal to 0. So we are not starting from 0, that is why I have put it len by 2 plus 1. Okay, so suppose initially, let's say I'm taking different examples of k. Okay, suppose n is equal to 4 and let's say k equal to 8. Okay, so let's say k equal to 8, suppose we are taking. This is our input. That means we have to look for SN4. So this is our string where we have to check the 8th bit. What would be the 8th bit? So in general, we are not creating the S4, but you can check it here. This is 3 and yeah, this should be our this red guy 1 should be our answer, right? So let's say go with the our approach. So k equal to len by 2 plus 1. So len is basically 15, right? Because it would be 2 to the power 4 minus 1, which is 15 only, right? So our length would be 15. So I'm starting with this 15. Okay. So what would the midpoint? Midpoint would be 15 divided by 2. So 7 plus 1, right? So this would be 8. So we'll check that, hey, if this k is equal to midpoint, yes, in this case this is equal to midpoint. That means whenever a midpoint is occurring during this series, we were actually adding the manually 1, correct? But we are starting with our inversion equal to 0. Okay, so in this case, whenever we are matching, this k is sitting at the middle point of it, and if invert is even number, okay, if invert is even number, in that case what we can say that value would be 1 itself, correct? So if this case is true, then we have to look invert number. So this is 0, that means it is considered as even. So in this case what we can return directly, we can return 1 as our answer. We can return, okay, character 1, okay. But this might not be always case. So we will take, don't worry, we will take the other examples as well, okay. So if this kind of scenario comes, we will check whether this is a midpoint. Yes, it is midpoint. Then we have to check invert. So if invert is even, that means that many inversion has happened already. So based upon this, we would be returning the values. So we will take more example to make it more clear. So if this fine, so let's say we are taking this time k equal to 14. Okay. So let's say I'm taking k equal to 14. Okay. So what would be the k? What would be this value? This would be 7 by 2 plus 1. Sorry, 15 by 2 plus 1. So anyway, it is still 8. But this time our k is 14. Means we have to look into the right half of it. Correct? This should be somewhere at right half of it. So in right half of it, this guy, this is the guy, right? 0. So we have to find what would be the mirror index of it. This would be the mirror index of it. Correct? Why do we need to find the mirror index? Because we know that whatever is there, whatever value is there, its flip would be our answer. For example, here is 1. At mirror index, it is 1. So if we get the flip of it, which would be 0, that should be our answer. So that is why whenever we are getting k equal to greater than this guy, okay. So if k is basically greater than If k is greater than by2 plus 1, in that case we are going to the right side. Whenever we are going to the right side, we have to find the mirror image. So how to find the mirror image? Mirror image index. So mirror image index would be, we can update this k equal to our whatever is the length of it. So length minus k plus 1. Okay, length minus k plus 1 would give us the mirror index. You can check here as well. So 15 minus 14 plus 1. Okay, this would give us 2. Okay, plus 1. So this is giving us 2. So you can confirm as well. See, this guy is sitting at 2. First and 2. 1, 2. It is residing at 2. So that is why whenever we are finding the k is greater than len by 2 plus 1, we have to update our k equal to this way. So now what is our k value? Our k is 2. And so we have to check in the left half of it. So to check it in left half of it, what we're gonna do is we're gonna make length equal to length by 2. So our new length value, what it will become? Length it would be divided by 2. So what it would be? It would become now 15 by 2. So 15 by 2 means it would become now 7. So our new length would be 7, because anyway we are checking in this left half. But now because we found it in the right side, that means our inversion, basically a flip would have happened, right? We did this inversion into the right of it. So we can increase our invert equal to 1. So from 0 I am increasing it by 1. Okay. Now we will go again. So what is the value of k? Value k is 2 and our length is 7. Okay. Now we will again come here. So we will check the midpoint. What would be the midpoint this time? So midpoint would be length divided by 2 plus 1. So length is 7. 7 divided by 2 plus 1. So this would be 3 plus 1. So it would be 4. This time our mid is becoming 4. But this is 2. Right? This is 2. Our k is 2 and this mid is 4. So basically we have to go to the left side. And k will not touch this time because anyway it is lesser. Right? So we have to check in the left half of it again. Correct? And we don't have to do anything in the invert because we are not going to the right side. So what we will do again, we will go to the length. Length would become again half. So what was the current length? It was 7. So 7 by 2. So new length would be what? It would become 3. Correct? So now we are checking here this half. Okay, this 1, 0, 1, 1. Okay, so we are checking in this part of it. So how would we do that? So again this is our new length 3, right? So and k is still 2. So what we will do? We will find the mid again. So what would be the mid? Mid would be 3 plus 1, 3 divided by 2 plus 1. So this would be 1 plus 1. Okay. So 1 plus 1, this is equal to basically 2. Correct? 3 divided by 1 plus 1. So this is equal to 2. Then we will check, hey, is this equal to our k? Yeah, our k is 2 and our mid is also 2. Correct? So that means we have to check that how many times this inversion has happened. This has happened odd number of time. So if this has happened odd number of time, what would be, it would be written, see here, whenever odd number happening, it is returning 0. Yes, we are anchoring for mid value, we are starting with the 1, right? So for the odd number, this is giving 0. So what will be, it will be returning us, it would return 0 for us. Correct? And you can check as well. See here, at this location, it should be 0. So we are getting it 0. Okay, so this is, believe me, so remember, we are making this for your understanding purpose. We are not creating any string. We are just based upon the knowledge of the length of it. We are constructing everything. Okay, so we got the answer as 0. So similarly, we can use this methodology, and we are not, this is an iterative approach, and we are not using at all any recursion, because even we could have done this in using recursion, but recursion takes the stacks inside. Okay, because for the all the calls we store them into the internally in a stack. So stack takes O of n size, but here we are not taking any size. Okay, so let me show you my corresponding code. I will explain again each and every line so that things would be very clear. Okay, so this is my code, you guys can see here. So see here, I have started this invert as equal to 0. Okay, and this length equal to 2 to the power n minus 1. So this is 2 to the power. So if we do 1 left shift n equal to 2 to the power n minus 1. Okay, now you can check here. So while k is greater than 1, So let me explain few more things here. So whenever we are looking for the middle pointer, we were looking for the invert, right? So this was happening only for middle point, correct? So as we know that middle point is anchoring for the 1, which we added manually. See here, when we started here, we added this 1 at middle point, then we added this 1 at middle point. So here we were checking for the middle point and it was anchoring for the 1 when we are starting with the 1. But this all things was happening while k is greater than 1. Okay, now you might have a question, why while k is greater than 1? Because finally when we will come to the k equal to 1, that would anchor for the very first guy. This is 0, right? So if this is 0, then we have to look that what is the total invert count value here. Okay, so let's take this example, further explain, let me. So see here, what we are doing here is, while k is greater than 1, okay, then we were doing the same thing whatever I have explained. So we are checking here that if k is equal to length divided by 2 plus 1, that means we are checking whether invert came odd number times or not, or even. If it is even, we are returning 1, okay, because midpoint is anchoring for the 1 and even number of time occurrence would give us 1, otherwise it will give 0. Otherwise, what happens if k is greater than length divided by 2 plus 1? That means we are going to the right side of it. Okay, so we were going to the right side of it, and in the right side of it we were looking for the mirror image, like we found here mirror image index. And for that reason we found here this is the mirror image index. Okay, so k equal to length minus k plus 1. Okay, and we are making invert plus plus because we are going to the right side of midpoint. That means one inversion of the left side string must be there. So that is why invert count would be increased. Okay, so we are looking these two values and every time we are doing length equal to length by 2. Okay, so then we will again checking. So whenever we are getting this condition true, then we are returning accordingly. Okay, but this is a midpoint and midpoint is only anchoring for the value started with the 1. Now when we are coming out of this loop, there could be a possibility, let's say for example, in this case, suppose our k was 15 itself. Okay, if our k equal to 15, what would be the mirror index? Our mirror index would be 0, right? The very first guy, which is 0. Okay, so for this 0, how many times, whatever number of time invert would have come, accordingly we have to return the way which here we are doing. Okay, so we will see here. So when we are coming out of it, let's say this condition is not matched anywhere. So what we will do? We will again check here that hey, invert came even number times or odd number times. If it came even number of times, we are returning 0, because see here we are looking for the till k greater than 1 we already done here, but for k equal to 1 means for very first string which is 0. So 0, if invert came or even number of time, then it would make 0 only, otherwise it would become 1. You can check it here. We started here with the 0, right? So 0 1 0 1. So whenever we are coming out of loop, that means we are anchoring for the 0 this time, because we are looking for the very first string. So for that reason, if we are not returning here, the k might have certain values which are not returning there, then we have to look for this way. For example, if k equal to 15 in our case, okay, so if k equal to 15 in our case, what will happen? We are directly coming to k equal to 0, right? K equal to 1 basically. So k equal to 1, what it is very first value which is 0. So we would directly come out of this loop, we would be directly coming here, and when we are coming directly here, what would happen? It would give us, invert would become 1, right? Because we went to the right half, correct? If it is 15, we would go to the right half, right? Here, this is the right half. In right half, we will make 1, correct? So in this case, what is happening? We are accordingly checking that if invert %2, it came even number of time, then we are returning 0, otherwise 1. So this is what we have to do. Let me execute my code. I am executing this code. So it is accepted here. Let me try to submit it. So I am submitting it. Yeah, it is 100% faster. So thank you for watching this video. If you guys have any concern, please make a comment over there. Thank you.